Hello, and we're here back today. I haven't actually done this in a while, so I figured I should start getting back into the habit when I start my streams to remind everyone that if you like this work I'm doing, if you think it's cool and you'd like to see me be able to keep doing it, I do count on people who are able going to mrforth.com/membership and seeing if you might like to get some of the perks of being a supporter or a member. So consider that if you're following along and would like to keep it going, because that's how I keep it going. So, what I'm doing today is I think I'm going to switch back to the RPG simulator, and I have a couple of reasons for that. I'm carrying a couple of big projects simultaneously, and everything I do is always kind of placed within the goals of all of them. But sometimes something I'm doing resonates very specifically with the goals of one project and not so much with the goals of another. And then I get blocked on that project because I've been neglecting these other goals. And so I went back and touched my object file stuff for a couple of days to give me more object file power, but I don't want to stay there. And I'm going to explain why, because that would be a very useful direction to go at some point. But the RPG simulator serves two purposes. One, it is helping me build up to an example that I can use that is like a real world practical example of a problem that I need an example of, and I can't fake it. And we're almost there. I've almost built enough RPG simulator to get to the point where I have a real world example of this. And I want to start building programs on my base layer that have like plug-in architectures, right? I want to be able to load in DLLs that use my base layer and have them work seamlessly with other DLLs that use my base layer and with a main program that uses my base layer. And my base layer mostly would just work fine without needing to think about that, except that it has a few features like a global logging and error reporting system that should only be instantiated once for the whole program, not once per DLL. And so a few things like that need to be carefully linked together and shared, where everything else can be more loosely sort of just each module can have its own copy. But then I also want to examine, like, is that better? Is it better to have all of this code? Is it a lot of code? How much would I be reducing the binary sizes if I didn't duplicate the majority of the functions into each module? What if they were all linked, and how would I want to wrangle that in that case? So that's the stuff I'm trying to get around to the point of being able to play with it and really get a feel for what's going to work best. And I just didn't want to use a toy example. I needed something with real meat on it, because the question isn't does it work in principle anymore, it's does it work in practice. And so I have to be in the middle of building something when I hit this problem. And so that's kind of one of the things the RPG simulator is set up to do, is to get me to a point where I can have a program that is on my base layer that also wants to have separate modules that come loaded in and plug into the system. And that's part of why I've been, building it the way I have the whole time. And so I have right now this concept of the combat module, which is defined here, and it's in this file and the C file, and it describes the only simulation I've actually ever played with in this whole RPG simulator concept. But part of the idea that I have here is that other mini games will arise throughout this game. You might stop at a shop, or you might be in town and have several different opportunities to talk to figures that help you. Or you might go, and this is what I'm going to do today, you might go into a chase sequence. You know how in an RPG you often have the ability to flee, and sometimes there's like robber characters, and they usually have the ability to flee, or like little fairies will show up, and if you don't catch them right away, they fly away. So there's such a thing as disengaging from combat in most RPGs. So I thought it'd be fun to take that idea and go one step further, and so you'd add in the concept of a chase sequence or a chase scene, where if you attempt to flee, a different minigame plays out that determines whether you get away or whether you get chased down and have to engage in combat again. And that game might be reciprocal, so that if the thief that steals from you is trying to get away, you can chase them down in the same simulation. Like the simulation is supposed to be somewhat non-privileged one direction or the other. The idea that one side is the player is left for someone else to think about at the level of the simulation coding, right? It's a symmetric game at that level. So I want to try and actually build something like that today. I haven't actually pieced together that second ambition of the simulator project yet, which is the ability to simulate more than one kind of scenario and then stitch them together with more complex rules. So I want to try to build that today, and then I want to maybe hopefully get to the point of, once that's working and feeling good, get to the point of splitting things out into DLLs. That very well might not happen today. That might be something that is still like in a week ahead of us from where I'm at now. But once we do start that, it's going to be a long project wherever it does start, because it's not just going to be about moving some code into separate files or building things slightly differently and removing some includes. Things like the ID system that I've already set up, the magic ID system, the magic array gather system, they're not going to work the same way anymore. And so we're going to have to think about what it'll mean to make these kinds of modular enum systems that need to also dynamically plug together at runtime. They can't be fully statically resolved, right? So we can fully do a full static resolve on each module's perspective, but then when two modules come together, there's going to need to be a what's the word I'm looking for? There's going to need to be a merging, another layer of handshaking that happens in order to figure out whose ID goes where through the whole thing. Does that make sense? Hopefully. And there's a couple ideas I can just rattle off of how that all might work, but I think I might as well wait until I've built the actual test case and have a thing where I can make it real instead of just conceptualize it, right? So that's where I want to be moving. And I said the RPG simulator serves two goals. The second goal that it serves is all along the way. It is building out this, I'm going to say, like, pushing in this direction of being able to code things in a different pattern. So that's, the story engine stuff that I used to do, some of the object file stuff is about having the tools to be able to piece things together in slightly different ways, and this whole new idea of C scripting that I have here, where if we go into the game scripts that I've written on stream here now, this whole C scripting thing is one of these ideas of it allowing me to piece together the logic in a different way by being able to bind logic to data more fluidly with the interface, right? So that's the second goal. That's the other reason why I don't mind coming back to the RPG simulator, because it's in line with one of the things I find most fascinating to work on. And in the short term, though, what I'm really hoping to get to is sometime in the next few months get my base layer cleaned up and ready to be published again, because I haven't done that in a while. Not even for the subscribers who have been paying for it for the last year. So I'd love to get them all an early copy, and then maybe by the end of the year get out to everybody a copy of the current state of the base layer. And I can't do that until I've really tested out this question of working with DLLs with my base layer. That's the new feature I've been working on since the last time I published it. So I'd like to mostly focus on moving forward with the RPG simulator and the to-dos related to getting to the point of testing that idea. So these other to-dos are still for later. All right. So with that, I think I'm going to pop open the Chase stuff. And right, so first things first, I was starting to, as I was thinking about this, I was starting to think about how I would want to rephrase the language for implementing the game rules of the simulation. So the tiles that I put together in these scripts have very simple rules. They each implement like one move or something. So they just apply a little bit of a light little bit of logic, but there's a lot of variety in the different ways these little bits of logic get pieced together to make the variety of effects and statuses and moves and micro changes to the rules. But then all of them get placed inside of a structure, and so the structure I've been placing them inside this whole time is this combat loop, and the combat loop has like phases and these things then say at different points along the way, like when they get new moves, when the hearts are getting decremented, and so on. They say, oh, like now's an opportunity for this rule to affect the state of things within this framework. And what I'd like to be able to do is make sure that this frameworking code is written in such a way that it has certain properties that I'm going to want down the road. Right now, the properties it has is you call it as a function, and so the main thread that begins this state cannot do anything else until the whole loop is completed, right? So if it's a 10-round combat, you can't look at each round from the outside calling code. You can only look at the result. So we could just simplify it down to a single step function, right? Here's how you update the simulation at the very least. Some other things though, and this is what I started doing as I was sketching out the idea of a chase sequence. At one point, I did this off stream, the sketching, but it was just sort of random first pass stuff. I actually need to read it again to see if I even still like the idea. And that's what I'm going to do now. So the way the combat was written, I sketched out what the new combat would look like that matches this, it looks like. And so there's, instead of having it be a loop, it looks like it describes, it's kind of like a new script type, except these are bigger scripts. And when we go into the combat state, there's an entering of the state, there's a step of it, there's a stepping of it like this. And then there's an exiting of the state. And I think the implication is whenever a combat state begins, you would enter, you'd call this. So the rules of the framework that runs these states would be, if you didn't previously run this step for this state, then you run the enter part. Then you run the step part whenever you're trying to step this. So you do a round of combat or whatever. Then the calling code will decide if it wants to step again or if it wants to transition to a different state. If it does transition to a different state, it'll call the exit on this one and then the enter on this one and then run this one, right? That's kind of the idea, I think. And so then the calling code can loop as much as it wants, and it can alternate, it can decide if it's going between combat and chase, right? Now, these two states might ultimately belong inside the same module when I go to do the DLL splitting, because it seems like they kind of relate to each other, right? They're actually two states implementing a larger total flow of game. But I think the structure of having this idea of states and being able to say that you're going between them might be the right structuring primitive to start with here. So I do still like this idea. This also brings up another thing I keep wanting to add to the to-do list here, which is experiment with C scripting for scripts with multiple clauses. Right now, let's try it this way. Right now, scripts with multiple clauses, like tiles and states, implement each clause inside an if structure. This is leading to two different issues. One, there is no data structure describing which set of clauses are implemented we try to gather this data structure in the case of tiles already by running the script in an init special init mode and saving each conditional. But this data structure also gets hard to is getting harder to infer this way as I pile on more intricate conditional expressions. For instance, I can't use an AND operator to compose two conditions into a new one. Two, without this data structure, we can't start optimizing the event handling machinery. Okay. And then the actual process of calling any of these clauses requires a lot of manual plumbing of state control registers or mode control registers and the runtime effect of this style is a lot of slop computing for each clause call. So that's a huge issue. And I am curious to get to the point of addressing it, but I think that's also a couple-day investigation. And for now, it might be a little bit more direct to just keep with the current style and get on with the idea of building it this way. So the whole idea here is that I would add in, just like I have tiles and brains that I can script, and they have different rules. I would add in a new kind of script called a state, and the state contains that sort of the framework that the little pieces plug into. So states would take in a player party and possibly other related parties or entities, play out some kind of mini game as many times as you ask for it to, and then go on to a different mini game according to whatever the control, like the simulation control, wants to do. Right, the implementation of state transitions will be left up to someone else. So the steps to making this work are I have to set up this new RPG state style scripting thing first, and then I can try implementing the chase idea fully. The reason I think I need to do the script transition first is that if I can only enter into a combat loop using a classic loop like this, then I'm not going to be able to interleave them. I could skip the state scripting thing, and just break this down into that's only being used for logging right now. So I could imagine just giving the step rule for combat and forgetting the logging for a minute for the begin and end. And then I wouldn't need to build the scripting system either. The state scripting wouldn't be necessary. I would just handwrite this thing and call it when I want. Let me read carefully if there's anything in here, though, that would have been different. Right. Calculate move set. Give moves is still the same. Characters make their moves is the same. Apply hits is the same. Release hits is the same. Eliminate HP. 0 characters is the same. Log is the same. Yeah, no, nothing is different. I mean, the only difference is right now the for loop version. Oh, wait, I'm comparing this thing to itself. I thought this was the for loop version. Okay, right, so that exit condition starts it, but then there's round. Calculate the move set. Okay. Give the moves. Characters make their moves. Apply the hits, release the hits, eliminate the HP 0, log. Okay, those parts, the parts that are in action are all the same except this exit condition, which is what I was expecting to find. And the exit condition is missing from this because this is just describing how you do the step. The decision of whether or not to stop playing this is now going to be in the hands of the control logic, is the idea. The outside, the calling code. So this would become the sim combat step function, and I'd forget about all this stuff for now. I think that that's a fine solution. That might be all I need. So yeah, so I think what'll have to happen is we'll need something like that's how you combat. Again, that's... There is this thing right here, which right now I still need. I think when I was thinking about the state scripting thing, I was thinking these things here, these things I called context, would actually be replaced with an idea of the state, whatever state the system is in, or whatever state is currently running, playing out, or whatever. And so And so I was thinking that the machinery would control setting up the actual context here. It is a little confusing because it has parameters too. So I don't know, actually. I don't know, actually, how I expect that to work. But I think now what'll happen is we'll do begin, and then we'll do step. We'll still need this, but we'll be getting it a different way. And this will have to be gone. That'll be gone, that'll be gone, that'll be gone. That'll be gone. That'll be gone. That'll have to go into RPG Sim Combat End. And then both of these need some way to get the combat context from the context. I'm pretty sure we have that concept. Module data or something like that. Right, so if I just go RPG module data, context, RPG module combat. This is combat, context does not equal 0. All right, so that's going to break. Right. It's going to break this part. But basically what we have here is so there we go. That's the current rule of the game. Right? Let's tidy some stuff up here. Okay. 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 I think I can see how this will work. Before we implement more of that, let's go into chase.c and chase.h, and we're going to, yeah, we're going to kind of recreate that structure. I think this will be good. Okay. So let's see here. Step rule for chase, I'll probably get from this mostly. Okay, so the rest of it is just wrong. Got it. This is something like what we want, but it's like, it's more like this. Chase context. No, we don't look at the chase context parties for this. We need to look at the parties this way, I guess. Okay, so not all of it is implemented, but that's the starting point. Let's get let's get this included so that we can actually see any compilation errors there might be. There's no hits during chase. Okay, cool. So now the next step here is I have to explain my idea for the chase rules, and I'm not entirely sure how I expect to make it all work. Like, I'm not sure what rules I want, but the basic idea I have is that here, everyone during combat makes their moves. There'd be a new spy here that goes check for flee. If party 1 is fleeing, or if party 2 is fleeing, we'll figure it out. So we go something like, not really sure how we'd best do this. Maybe it's just something like combat context flee memory 0 array. If combat context flee 0 or combat context flee 1, then we're going to do the flee logic, which basically goes, if they're both fleeing, we'd go into disengage, and I don't have, there's nothing that happens after disengagement. That would just be a new way that my simulation can end, is that the player did a flee and the NPC did a flee, and so now they're not engaged in combat and it's over. I don't know what would happen next. Maybe the next combat encounter would just begin after that, if there's a chain of combat encounters to simulate. If one side did the flee but the other side didn't, then the other side gets the opportunity to chase, and that's what the chase rules should be. I think what would happen here is we detect that one side is fleeing, and if they're both fleeing, a disengagement occurs. If one side is fleeing, we then say, okay, either way, once we've seen any of these, we don't do this path. Hits get ignored when one side chooses to flee. And then if one side did flee, what we need to do next is we need to finally decide, whenever we do one of these step things, how do we raise a result to how do we return the result? Sometimes we're saying we want the controlling code to decide what happens next. But at the same time, I need some way for this code to encode a message back to the caller that says, I'm thinking the right thing to do is transition to chase state with this party as the runner and this party as the chaser or whatever. The question is, does this say something like RPG transition state context RPG module chase RPG transition param context, runner chaser or something like this? Do we have is this like a vlist kind of a varargs thing where I can just put in parameters that way? Will it be more like this? Maybe this might be the way I like it. Yeah, so So this way of doing things means that this code knows about chase, right? And so combat and chase are going to be related to each other. Um, and it would mean that the controlling code is a little bit more of a generic machine, which would probably look something like this. It'd be like I mean, it's basically this, right? State. Um, I mean, this is just actually gonna be this. Now that I think about it, right? Like this is the same thing that I was doing here. Set up my party. I transition into a state to get started, and then I sit here as long as context state does not equal 0 or something like that. So this would set up the transition into the correct state. And then this would just run over and over again. So this would run, and if it says transition here, then it's decided where things go when the flee happens. I think what I want, though, is the ability to imagine that this code might be running under the influence of other statements that have been made that modify the meaning of this code. It's kind of like how what protect does is say whenever or protected does is say whenever a character has a protected tile and they take damage, we modify the meaning of that damage like this, and then this ends up meaning that we don't know, like this statement is being applied to a character. There's kind of such a thing now as I'm saying, like I want to have a statement about the way combat is set up so that a transition to chase with these parameters might mean something different, right? And so the question is, what would that statement look like? Who would have been the one writing it, and how do I implement it? So the kind of statement I want to be able to make to modify what this means is Well, the one place where I want to be able to make a statement that modifies the chasing rules is I might from the outside want to say, like, in the current setting, the rules include that this party cannot run. Maybe one party has the ability to flee, but the other one is cornered, right? Or it might be that neither party has the ability to flee, but that doesn't actually affect this. That would affect the moves that have the ability to flee in the first place. That would be parameters to the combat context that say whether or not those moves are available. And of course, I haven't even gone through and set up the thing that gives you a move that lets you free yet. That's or flee yet. That's another issue still. But there is another kind of statement that I want to be able to make that affects this, which is as we transition into the chase, I might have used an ability or something, right? Say I have I've always got the ability to try to run unless that gets ruled out. But then I might say, well, I have a move here that says, um, yeah, and this is where how I want things to shake out does matter a little bit. And let's imagine just the kind of thing I might have. At some point, I might like have a tile that's like a blink move. It's a magic spell, blink teleportation, which is able to give you a huge advantage at trying to run away, right? But it doesn't make it possible to run away if it was previously impossible to run away, right? That's an important distinction. It only modifies the rules in the sense that it gives you a much bigger advantage at trying to run away, so that if it was possible but very difficult before, it might suddenly become possible with a blink spell, right? So the things I might want to say are not things which modify the transition of the state, but rather things which occur within that state, now that I think about it. I mean, the question is, how do I want the interface for interacting with this to work? What's the logic here? If I'm in combat, can I use the blink spell? And is that different from using flee? Or is it that I first will flee and then that will take me into a chase sequence, a chase, scenario, and that there in the chase scenario, I will have the choice to use blink or not. The thing that I'm thinking is more like in combat, you can choose to use blink, and blink says, run away, which is already a move you had an option. You'll have been granted the ability to use the flee move, the basic flee move. So this will say, run away and +5 to your run your like this character's speed score for the chase sequence or for the chase mini game. And if you can choose that during combat and it affects the rules of the chase, that's where things get interesting, right? So maybe what I should do is not worry about that part yet and just get to the basic version. I don't know if that kind of a tile, if that kind of a move would affect the transition state idea here or here, but somehow it would have to affect the final state or the final initial state of chase. I mean, really, I think what it might come down to is I might need to implement chase first just because I need to know the rules of chase a little bit. Because once I know the rules of chase, I'll know how to hook into it from combat tiles like blink, right? But I haven't really spelled out the rules of chase and put down the vocabulary for it. So maybe before I do anything else, including this, for now, we'll just go combat context. Hey, can you throw in like flee 2 and leave it blank so nothing will happen? We'll just do combat like normal still. And don't worry at all about this idea. That's out there still. We're still in this land. And everything still works. So What if I did this, but with chase instead of combat? Well, right now what would happen is apparently nothing would change because I didn't rebuild. Here we go. So now, right now what would happen is we'd run 100 rounds and then be done because nothing happens during the simulation of the chase step. Sim chase step. Chase context, runner, chaser. Characters make their moves. Okay, here's the next rule. So in combat, what's happening is when characters make moves, they do attacks, and the attacks cause damage to each other, and then they can do other stuff that can affect each other too. In chasing, what happens is characters are not exchanging damage, but they're each scoring a speed score. They're each trying to generate speed. And then if the minimum speed of the runner party, you score each party by looking at the minimum, whoever's slowest, right? So the party sticks together for now. We might add in a rule that the chasers can leave their slower behind so that, you know, you re-engage in combat, but for the first round of combat, only those who are fast enough to catch up are the ones in combat or something, right? There's ways to continue to flesh out this the gradations of the rules here, but for starters, let's say the parties are going to always stick together, and so the slowest one, we'll simulate it as the slowest one is the speed of the whole party, and then if the runners are faster, they disengage. It's like they win. It's the end of combat, or it's the end of the engagement at least. If the chasers win, then the system transitions into a round of combat where fleeing is not an option for one round. They have to stand and fight because they got people catching up to them. Maybe the rule is they can't flee at all. They have to keep fighting if they flee once and got caught, or something like that. Or maybe they flee, and when they get caught up to the other round, gets an advantage. The other party gets an advantage for a round where they can't flee or respond or something. Right? There's a couple ways that the simulation and game design might play out there. So I want to be able to explain those. I want to be able to put together those various flows. Characters make their moves. But the main thing is we need to score speed for each party. So what we'll do is say the chase context has a list of these speeds, and each speed Um, okay, this is going to be something like score speed for each party. Why don't we do... First, we'll scan each party and set each character. Wait, can the parties have speed tiles? That won't even fix the problem. Okay, it doesn't matter. The character is gonna have a speed tile, which is gonna get initialized to 0, right? So each character's speed tile gets initialized to 0. And then we're going to loop through all of the speeds, and for each one, the speed on the given character is going to be used to increment the total speed. And then for each party, we look across these again, and we do tile count. Is it tile count? Yes. Count the speed tiles. And use that to update the party speed with a min. So we'll get the min speed for each party. And so to make this work, we just need to throw in a new tile. So we'll start spreading our tile scripts around now. Chase tile scripts. We just need one like this called speed. And we'll have this one be just a hidden counter like that. Okay. Hey there, Young Lane. Welcome. All right. Determine the winner. If party speed 0 equals party speed 1, then we don't have a winner. And so why am I, that's the opposite of what I want. I want if this or this happens. So if this happens, then party 1 catches up to party 0. The runner speed, this is, you know, I guess let's actually apply names now. Runner speed equals party speed 0. Chaser speed equals party speed 1. So this is runner speed is less than chaser speed. This is runner speed is greater than chaser speed. So if the runner speed is too slow, that's where we transition back to combat with the modification to the combat rules, at least temporarily. Yeah. So, um, again, this idea of needing to be able to read the results comes up. I wonder if it would be better to just have something like enum RPG chase round result, right? And then just be able to say what we're really doing here is we're setting a result code. So it could be that we have chaser win. It could be that we have chase round result runner win. And then the other possibility is that they have equal speed. And so to call this step function, you actually have to know what it means, I guess. Right? It's just I don't like that. So for now, I'm going to do that because that lets me move forward with putting these into a loop. And what we'll do is we'll go chase round result equals if round result does not equal speed, then we'll break out right there. And when we go to log each round, we'll throw in the speeds. Right, this is speed. Chase round result. Then we got to implement these things. These are going to be like combat hits. But instead of being called hits, these are going to be called speed. Instead of being for combat, this is for chase. So this will be RPG, speed, gather, begin, chase, context. I don't use any nested functions in my code, no. I don't know if there's... I like to be able to run on Windows and Linux common compilers, so I use CL Clang so that I can run on... So I can compile on both pretty routinely, and so I tend to stay away from anything but the simple extensions that I can use, like run before main style stuff. Okay. Okay, so now we're almost there. In the combat.h, it introduces some script operators that I think Chase will also need to have a similar version of. Unfortunately, the naming is going to become a problem, isn't it? Technically, I don't know if we need that yet. I want to just keep it as simple as possible. Go with just that one. Just to avoid making hard decisions. And this just becomes... Oh. Chase. Combat chase. I'm getting pretty lost in thought about how the various aspects of linking these things up across the DLL is going to work later in my head right now. It's interesting. I think the hardest part is going to be there's still going to be a need. So an issue that I'm also working through here is it's the path from writing all the simulation code to being able to have a player, a real human player interface controlling one of the parties is another thing that's always on my mind. And the way that I imagine this working is that these state things, like the chase step rule here, what I'm thinking about here is whatever I write here, when it involves decisions in the middle, this has to go on a coroutine ultimately, right? This logic has to live in parallel, or at least concurrently, to the logic of the interface that answers the question, how did the human run their brain, right? When this happens, the human has to run their brain, and therefore an interface problem shows up. And so this code waits for the human brain to make its decision. Wherever we make a decision like that, wherever we choose to structure things that way, though, all of the state leading up to the series of decisions made by the human is unserializable, right? We can only get back to a point where we can serialize our state once we exit this function of the coroutine. So this essentially represents a turn. If the human gets to here and then starts doing stuff, and then they close their game without finishing this call, then this quote-unquote turn doesn't complete, and so their save game is at the beginning of whatever stuff they did. And I've just been sort of sitting here sorting through some of the ideas of, like, if I'm going to start having these state transitions be hard-coded and then hooked, I think I can see how it can all work. But the way those hooks are going to interact is more complex. And then I went down the path of thinking about how handling hooks, like right now, tiles basically say when this applies, when this situation is true, apply this rule to the game. And that works, but it won't work quite that easy for this, because if I'm going to say something like, oh, in this case, when we go back to combat, apply this modification to the rules for one round or whatever. This is a combat with the fact that this particular party in the combat just lost a chase, so they have some kind of penalty applied, right? In order to express that logic, if the logic is going to include, like, for a round they cannot flee, it feels like something's happening there that's like a move happens or a rule gets applied in one state that says something like, if this happens, then when this other thing happens, reinterpret it this way or modify its interpretation in this way. And so I was just kind of sketching out how, if there's multiple of these handlers both trying to modify the interpretation of an event, I can see a way where it can compose automatically still, but it's not just a matter of running each one. They have to nest it to each other properly somehow. And I think I was seeing the idea, but it's a little hard to fully explain, I think, because I'm not sure that I'm even making sense as I say it now. Cool. So still nothing happens because both parties just generate a speed of 0. This is going to be a new kind of tile, sort of like the attack tile. So it's an action, or I guess it's a quick action. It's not going to be hidden. When this gets used with the chase module, give us a chase context. And we're going to look at the holder entity. We're going to count how many run tiles they have. So the count on the run tile tells us how much speed the holder generates. It doesn't affect the enemy, right? Now, what gets weird here is how do we start setting everyone's run tile? Because I've never thought this through before, but I think my assumption let's go back to the scripts. My assumption here is that the mushroom has a speed of 0. The other characters all have they all have a run of 1. Now I'm encoding hearts with tally marks and attack with a number there. And then other tiles this way. I want to be able to say, set a default where run equals 1, and then somehow modify the default here. But I haven't really got syntax for that. I could go over here and give each of these 1 run, and it'll work. Let's check this out. So if I get a brains, if I look at this brain scripts for something simple like attack, can I make a similar one for run? So the rule is, if you can use run, then use run. So there we go. This party here I see what's happening. Am I running these against farmers? Sim.c. Yeah, it's the farmer party. What if I'm looking at this and I'm thinking, yeah, I need better ways to script stuff up. I need to be able to say something like this. I need to be able to now change the system so that I don't have to give everyone a run manually. And instead, over here in Chase, I can set header. What is this? This is script game. Is it operators? Header fixed max. Right. default count, I could say that we can just set tiles as having defaults, and then that's the same as saying when you create one of these, when you create any character, if you don't have a specific value for this tile, then instantiate it with this particular value, right? Now everybody would get one. And then I would have to update my syntax so that this is something I can deal with. Right now I set a tile by going like that. Let's play with this. What if I put the number here? So if I ever wanted to do something like, I could actually also end up eliminating the attack, and then this would become like plus plus 2 attack. But then farmer would just be plus plus plus. You wouldn't need to write the 1. I could drop the syntax where I use a number for the attack amount entirely. I can set the default attack to 1, so that if you want a 0 attack, this would become, you know, no attack, no run, etc., etc. And then the numbers could go right before the number, the tile, like this. So no number indicates a 1. And then a number indicates how many of the tile to use. Or I could start putting the counts after the tiles now. Or I could go like this when there's a number. I could start thinking of it like this. Run equals 0. But of course now I'm changing the syntax quite heavily, but it would be like run equals 0. Attack equals 0. attack and run will just take defaults, protect. Or I could see keeping the tally marks for hearts as a convenience, right? And then farmer is like this, and sleeper is like this. The nice thing about having the braces in the syntax is that it makes the spelled out versions with lots of tiles and numbers clearly delimited some other way. Like now I can put commas between these, which I couldn't do before, for instance. This starts to look almost Metadesk-like, right? The nice thing about not using the quotes that way, for the purposes of this sort of setup of scripting, that gets a little bit nicer is that I don't have to embed them inside a string, right? I'm embedding them in a string, so it's more like it's going to look like this. Because the parentheses The parentheses work to delimit it without it colliding with the quotes. These ones will get harder though, right? I guess if attack has a default of 1, this wouldn't be harder. We would just eliminate the numbers there. This is the one that will break with the change in to having defaults, because it'll have an attack of 1 even though I left as nothing there, right? There's no number there. That'll go to meaning attack of 1. These will all become wrong or right, but this one will be wrong until I add the ability to control the counts on these. What if I wanted to do something like this? What if I wanted to just mark some characters as stationary, so that instead of saying that I'm going to manually override the defaults, which I could still add as a possibility. The cool thing about doing it this way is now I can ask, how do I implement the concept of stationariness so that whenever something is stationary, it'll have an attack and run of 0 by default instead of an attack and run of 1. That's an interesting question to me. The stationary could be a Boolean, right? So it kind of introduces this idea of, like, during the initialization of a character, the set the set of defaults might want to be affected by the tiles that are there explicitly. And so there's sort of an initialization pattern that's going to get more complex, where first you set up all the tiles that are actually specified as specified, and then you figure out if there are any that were not referenced, what their defaults will be, but their defaults will then be modified by the tiles that are already there before they get added. And then the question is, does stationariness have to know about all the things that rule it out? Or do I declare stationariness first and then reference it from attack and run? Right, because this could look like something like if right? Just like with the game scripts we've already got, the heart does this. Okay, so it's like this. Except I'm pretty sure it's an amount pointer in this case. Protected. Yeah. And so now run is saying if the character is stationary, you cannot increment me. And so the default of 1 will get avoided. But it gets more complex than that. I don't think that's a full story yet. All right, I'm going to go a slightly different direction here. For now, I do not want to go down the road of adding in defaults or changing the syntax. So instead, I'm going to say we actually are just going to expect to specify this when it's possible, and most things will have to specify it. So that's fine. And then later what I'm going to do is I'm going to try to come up with a plan for how to expand out a set of tiles to create a character from some concepts like a stationary or walking, right? If I would mark all of these as walking instead of having the ability to run, or these would be like biped or something, right? And so it's like a character type tile, which sort of is a L system kind of thing, or a multi-set programming thing where I go, oh, we have biped rule. Well, that implies a run tile and an attack tile and so on and so on. But I haven't got a full system for that yet. And the reason I want that is because there might be, like, if I have a flying character type instead of a bipedal type, then instead of getting run, it might get fly, and fly is going to be better for certain circumstances than run in a chase scenario, right? It might generate more speed, or have abilities like have the ability to be sort of unmatched without a competing fly option, right? Might be better than speed. We'll see. But the I gotta figure out where I want to go next. I think I'm getting caught up in one of these tile programming questions when I'm trying to push through to something else here. So here, our runner party is able to generate speed and get away. And that's cool, but I kind of want to see what happens if we flip it. Right. Party 1 is going to be the shroom party. Party 2 is going to be the farmer party. They're going to give chase to the shroom party, And so they end up catching up, right? Either way, it still ends. But now this party is winning. What should be happening is when the round result of chase is a transition, or is that chaser wins, there should be a transition to a combat state. So I think I do want to set up this state transition language, having sketched this out now and looked at how this all works. I could set up here the entire state machine logic, which is like we're either in chase state. Like, let me show you what that would look like here. Now, if the round result is that, well, I guess there are a couple outcomes. If the round result is that they have equal speeds, then nothing will happen. They'll just continue the chase sequence. If the round result is that the chaser wins, then chase state equals 0. They've moved into combat state. If the round result is that the runner wins, then we have an exit condition. We could just say I equals 100, for instance. It's the end of the engagement. And that's what happens while we're in the chase state. And then if we get out of the chase state, we find ourselves in the combat state. Sim chase end context party, yeah, like that. Now this will kind of work. But that's only because party 1 is the only one that's capable of doing the chasing on, and party 2, like the, how am I trying to put this? There's not going to be a case here where the chaser changes. So if there was, constantly passing my local party 1 to the chase function would be a problem, because if we were in combat and then party 1 was the one that ran from combat, it would become the runner and it should go into this parameter. But right now, nobody can run from combat. That hasn't been set up yet. So this will technically work, but only because most of it can't happen. Most of the possibilities in the game rules of the game can't even happen yet. But it should show us the correct rules for the current pieces we have. So if there's a chase, they catch up, and then they go into combat and complete a normal combat. So that's what it should be like. Except if I were to say, Let's put the farmer party instead up against the goblin shroom party. Since they have shrooms, they can't get away, and then combat begins. In theory, though, at this point, maybe they can run because party 1 loses all of its mushrooms. Now, it didn't have to, but it lost all its mushrooms. After one round of combat, which is kind of unlucky. Once it's down to just the one big goblin with the 5 HP max, that one can run. And so it should be able to go back to the chase state here and be the runner. So I think that's where I'm going to pick up next. I've been streaming for about 2 hours. Now is probably a good time for me to stop for lunch and clear my head. But I think when I get back, I want to figure out how I can structure things so that this can go back to a chase. And then I want to examine the question of like, how are things going to work if I constantly have to manually control these states? Obviously, I could switch from a Boolean to a state enum code, but I'm still going to be hardwiring in the logic of these transitions. And I'm pretty sure that what I really want is to write the transition logic, the default transition logic into here instead of setting a result. Right? I think what I want to have is, in this case, I call for a transition to combat. And then what I can do is have this plan down the line that calls for transitions to other states can actually be hooked and transformed into meaning something else by the context that set up the code in the first place. And that way it'll become more like this again on the outside level. Although not quite. Like, we'll be able to say something like run combat with this modification. Well, yeah, it's going to be interesting to figure out how this works. Maybe the states provide their own function for calling into setting them up to transition into them. We'll see. Well, anyways, I'm gonna go get that lunch, think this through, and we'll see what we come up with when I come back later today.